everyone, my name is Piramon. I'm a Material 5 DPST Scholar of Higher High School, and this is my project, Soil Salt Optics. Soil Salt Optics is one of the LYPT 2019's programs that I have experienced to attend LYPT Camp of Thailand. And this program said that using a laser beam passing through the layer of soil salts, thermal lens effect can be observed. And they want us to investigate this phenomenon. So this is my first time knowing the thermal lens effect, and this effect can happen in soil salts. So I think it's like to learn physics in our kitchen, and I want to know which parameter that affect this effect. So I'll talk about motivation, theory, experiment, that there are experimental setup, and 2 experiment in my work, effect of laser power and effect of soil salt concentration on beam size, and discussion. So what is thermal lens effect? Thermal lens effect is a lensing effect that caused by temperature-dependent refractive index when a Gaussian beam converges an absorbing medium. And we know that Gaussian beam is the beam that have the peak intensity or the highest intensity at the center and the lower intensity continuously. And because of the intensity, the electromagnetic energy will convert to heat, and it is absorbed by our medium, and it will cause temperature gradient, and temperature gradient will change the density of our medium, so it can cause the refractive index gradient. And to analyze the length of the focal length, we will see that this is the relation of focal length and the MIDT or thermal optic coefficient. If our medium's thermal optic coefficient is positive, our lens will be convex lens, and if it is negative, will be concave lens. And to analyze beam size, we will use Gaussian function that intensity at distance r equal to peak intensity times E power minus r squared by w squared, when w is the width of the beam, and this is the relation or the equation of W1 and W2, when W1 is the beam size before it has the lens, and W2 is the beam size that we can detect from our camera. So this is my experimental setup. I use laser, convex lens, sample, filter, and camera. And my medium or soil salts will hold in a glass cuvette which have thickness at 90 micrometers and with laser beam. Okay, and this is schematic experimental setup. Laser beam I use at lambda 532 nanometer, and use convex lens to focus sample at the focal point, and use digital filter polarizer as a variable filter, and use CMOS camera, which have intensity dynamic range 0 to 255, and it is the reason why I have to use variable filter to control the intensity. And this is the example of the beam picture that can detect by my camera, and I use MATLAB to analyze the beam size. So beam analysis. Beam intensity profile will be determined by fitting with Gaussian function in my MATLAB code, and in this study, beam size will determine when at the W that intensity equal to peak intensity by E. Okay, and W1 is the beam size at focal point, and it is equal to 66.912 micrometers, and the distance between sample and camera is 12 centimeter, and W2 is measured from our experiment. So let's see my experiment. Experiment 1. Effect of laser power on beam size. And in this experiment, I used laser power at 4/12 to 60 milliwatts and soy sauce 100%. As you can see that there is two results. This is the beam size from soy sauce in the glass cuvette, and this is the beam size from only glass cuvette to be the reference. We will see that from the soy sauce, the higher laser power, the beam size will be bigger. So we can conclude that our soy sauce have the thermal optic coefficient negative, and it make the result be like it past the concave lens. And when I use only glass cuvette, we see that the beam size is smaller towards laser power. So this is positive thermal lens or convex lens, but the result this is not distinctive that glass cuvette also can cause thermal lens effect, so we can neglect it. Conclusion: soy sauce exhibit a negative thermal lens as the beam size increases toward the higher laser power. And the effect of glass cuvette are positive thermal lens effect, but it's not distinctive, so it can be negligible. And experiment 2, effect of soy sauce concentration on beam size. I use pure water to dilute soy sauce concentration at 20, 40, 60, 80 ml. And use soy sauce, pure soy sauce 100%, and evaporated soy sauce at 120%. And I'm showing the beam intensity profile at laser power 50 milliwatt of 6 soy sauce concentration. This is 20%, 40, 60, 80, 100, and 120. So you will see that the higher concentration, the bigger beam size. And I do the experiment from 3 power laser to ensure my result, and it shows that they have the same trend in every laser power, and this is the conclusion. It's because that the more concentration heat is absorbed better. So we know that our soy sauce is a negative thermal lens from experiment 1. So if it can absorb heat better, so the diffractive index will lower, and so the beam size increase toward higher concentration at every laser power. So the discussion: calculation of thermal lens focal from W2. In this case, if we do the experiment to find samples diffractive index, to use with this equation, that you see that there is the relation of W1 and W2 at the focal length, and ZR, when ZR is equal to this and have the refractive index. So if we know the refractive index and put it into this equation, and then use this equation from W2 that we can find in the experiment, then we will know the value of focal length. But the discussion too, there is thermal lens effect that caused by glass. In this case, we can analyze with the Q parameter 1 and Q parameter 2, that this is the relation of Q1 and Q2. ABCD is from ABCD matrix that the matrix talk about the translation of the beam. So in this matrix, it includes the focal length of the glass, focal length of the thermal length, and then we will analyze from the W2 that we can detect from the camera too. So use the relation of Q parameter and the metric. It can give us the focal length of the thermal length. And I would like to thank you for Dr. Chalong Ratnangam, Prince of Songkhla University Physics Department, and Mr. Pasomlang Singh Hayathai School and DPST and IPST. And my project is not yet complete, so if you have any question or discussion, you can comment anyway. Thank you for your kind attention.